Welcome to the presentation of PRITS series game. This game has been developed in collaboration with AlbaSim Research Axis of the School of Management and Engineering Vaud and HESAV, School of Health Science Vaud. It aims to support the courses on patient rights given at HESAV. In the game, the player assumes the role of a caregiver and his objectives are to meet the needs of the patient while respecting his rights. The idea is to make students aware of patient rights and to give them an idea of the situation they might face in their profession. This game will be used initially by about 100 HESAV students and can be used in class or remotely. This presentation is divided into three parts: a demo of the game, how does it fit into a pedagogical scenario, and content management. Let's start with the presentation of the game. When accessing the simulation, we first see the home page with a set of thumbnails. Each card represents a patient with a brief description of his pathology. I choose Mr. Horiu's card. Here I can see a description of the patient and his pathology. I'm also learning about my role as a healthcare professional. Let's start the first meeting with the patient. On this page, I, as player, discover the specific objective of this meeting. The patient begins the dialogue, and I have a choice of replies. If I need to, I can go to the literature to find some guidance on how to better manage this situation. The patient will react to my answers. His reaction depends on my choices. As I continue, I will be faced with new choices that challenge my patient right knowledge. When the dialogue is over, I can return to the patient's home page. In this case, the completion of the first encounter has unlocked a first set of exercises. Teachers can determine the type and the number of exercises to be done after a dialogue. For example, single answer questions, multiple choice questions, or questions that require for custom text or answer. The completion of exercises unlock new dialogues, exercises, or documents. Now, I would like to discuss some of the choices made in the design of the series game, as well as the modalities for its integration into a global pedagogical scenario. A simulation is a reproduction of reality. When developing a simulation, we must ask ourselves what part of reality we're trying to reproduce. In this case, the encounters parts create an immersion by reproducing a professional situation. Thus, this game tends to create cognitive fidelity rather than physical fidelity. Physical fidelity would have been to try to reproduce the audio-visual reality of the relationship with the patient, but instead it is focused on cognitive reality. In other words, reproducing the thought made by the health professional in this real situation. In order not to break the immersion, in the simulation as in reality, there is no feedback on what is right or wrong. The debriefing will be done outside of the simulation. The simulation by itself isn't a game, but can be seen as a gaming and motivating factor, especially when it encourages the user to be reflective. Although PRITS is mainly based on simulation concepts, the possibility of progress by unlocking activities is a classic game mechanic. It gives an idea of challenge and encourages the user to progress in the game. The PRITS game is only one part of the pedagogical scenario. The activities surrounding the simulation are as important, if not more, than the simulation itself. It will therefore be integrated into a global pedagogical concept, including activities around it, before, during, and after. Before, students may have a general introduction to patient rights. Next, a pre-briefing should ensure that students understand the objective of using the simulation. During the encounter, it is possible to access documents. This can be seen as a kind of problem-based learning approach. The aim is to encourage students to acquire by themselves the knowledge that will enable them to solve the problem they are facing. In addition, social constructivist approaches are also used. For example, students can work in groups, allowing them to confront their opinions before answering a question. After encounters, exercises are intended to complete or reinforce what has been experienced in the simulation part. Then, a debriefing phase on what has been achieved is also planned outside the software. At this moment, the teacher can also provide additional theoretical contributions. After having seen the game and its pedagogical integration, let's look at the hidden side of the software's operation, content management. To develop such a simulation, it is necessary to collaborate with a multidisciplinary team. The PRITS project brings together the skills needed to develop the game, which are health, law, pedagogy, and engineering. And in this type of collaboration, several questions arise in terms of content management. How do you allow jurists to participate in the creation of content? How to allow teachers to adapt the content to the evolution of educational objectives or to the evolution of the law? Thanks to the developed authoring system, the content can be edited directly in the game interface. The same tools allow editing more complex content, such as dialogue. Dialogues are created in a visual way. The interaction sequence of the dialogue is modeled like a state machine, as a flowchart. This allows to see the entire dialogue as a single picture. In this case, the states, dark blue boxes, represent what the patient says, and the links between them, with the light blue boxes, are the choices the user can make. The same tools can be used to design exercise or manage the activation of dialogues, exercise, or documents. The experience with the creation of PRITS has shown that this simplified content editing solution have allowed non-computer scientists after a short training period to create new patient records. To end this presentation, it is to be stated that the PRITS project is supported by the Digital Competence Center of the University of Applied Science Western Switzerland, and also that it is being used as a use case in the Swiss National Science Foundation project, CoLab. Thanks for watching.